What's up, my dudes? Today we're going to look at area and perimeter on the coordinate plane. So we're going to have to plot points and find the area and perimeter. So on this first example, they asked us to draw and classify this polygon given by those coordinates and then find the perimeter and area. So first, let's plot these points. So my points are plotted, and I'm going to go ahead and draw this guy by connecting the dots. And so cool. It kind of looks like it's a parallelogram, but to be for sure, we need to check out the slopes. So I'm going to check out the slope of segment HJ, where I go up 2 and over 1, 2, 3, 4, 5. So I have a slope of 2/5, and LK up 2 over 1, 2, 3, 4, 5 so has a slope of 2/5 as well. And I notice since HL and JK are both vertical lines, they're automatically parallel. And since HJ and LK have the same slopes, they're parallel. So I know, because it has opposite sides that are parallel, that this is a parallelogram. So that means the formula that I'm going to end up using to find the area is going to be the area formula for a parallelogram. Area equals base times height. And for the perimeter, we'll just add up all the sides together. The sum of the sides. So cool. So this problem will start by finding the, let's find the perimeter first. So to find the perimeter, I need to know all the side lengths. To find JK and HL, it's really easy, because they're vertical lines. So the length of JK we can find by just counting 1, 2, 3, 4, 5 units. And since it's a parallelogram, HL is also 5 units. Now I need to find the other two sides, LK and HJ. And I know they're going to be equal to each other because it's a parallelogram. But since it's not a horizontal or vertical line, I've got to use the distance formula. So to use the distance formula to find LK, I'll do that. I'll do it right here. LK equals. So I'll call this x2 and x1, and this will be y2 and y1. I really just think of it as the difference of my x's squared plus the differences of my y's squared, which looks an awful lot like Pythagorean theorem. So we'll say x2 minus x1, -3 minus 2 squared, plus -1 minus 1 squared. And that gives us what? -5 squared plus a -2 squared. So the length of LK is going to be equal to the square root of 29 units. And that means that HJ is also going to be square root of 29 units. So cool. So now I can find the perimeter, and the perimeter is going to be the sum of all of the sides. So I'll add up JK and HL, so it'll be 5 plus 5. And then the other two sides, HJ was square root of 29, and LK was the square root of 29. So let's add these together, and our perimeter is equal to 10 plus, and I have two of these guys, so let's say 2 square roots of 29. Now if I were to throw that into a calculator, it should give me about 20.8 units. Now we're going to find the area. And we're going to use the formula of base times height because we decided this is a parallelogram. I'm going to call this, we'll call JK our base. So our base, bless you, has a length of 5 units. So our base there is 5. Now let's look at our height. Our height has to be perpendicular to our base. So it has to make a 90-degree angle with JK. So I'll make that little segment, which comes out really nice because it's a horizontal line and I can easily count its distance. It has a distance of 1, 2, 3, 4, 5 units. So the height of my parallelogram will be 5 units long. So my area is equal to 5 times 5, 25 units, and its area, so it'll be units squared. So in this problem, we saw that we had to use the distance formula to find the lengths of those non-horizontal or vertical lines, segments. Opposite side. And on this next example, we are going to do the same thing, draw and classify. So let's plot the points right now. Alrighty, so we got our points plotted. Now let's connect them. Let's decide what type of quadrilateral this is. Alrighty, so looking at that, it looks like a parallelogram. So I'll check out its slopes. Slope from E to E is up 2 and over 3. So m equals 2/3. The slope on the opposite side from G to F is also up 2 and over 3. So m equals 2/3. It's looking like a parallelogram so far. Let's see if EF is parallel to HG. Has a slope of down 1 and over 3, so m equals -1/3. And H to G is down 1 and over 3, so m equals -1/3. So the slopes are the same, so those sides are parallel as well. So basically I just found out that this was a parallelogram, even though you probably thought that to begin with, because it looked like one. So now that I know for sure that it's a parallelogram, I know that the area will be found using the formula area equals base times height. And then I'll have to find the perimeter as well by finding the sum of the sides. Alrighty, so let's start with the perimeter. So I need to find all the side lengths, and since it's a parallelogram, I know its opposite sides are congruent. So when I find EF, I'll know what HG is as well. So let's start with EF. To find the length of EF, I'm going to have to use the distance formula. All right, my distance formula says that I can do x2 minus x1 and y2 minus y1. So it's going to look like 2 minus -1 squared plus -2 minus -1 squared. All right, simplify that a little bit. It looks like it's going to be 3 squared plus -2 plus 1, -1 squared. So it looks like a 9 plus 1. So the length of EF is equal to the square root of 10. And since EF is equal to the square root of 10, that means HG, the opposite side, is going to be equal to the square root of 10. Cool. Now I've got to find out the length of the other two sides. So I'll find out the length of HE and GF. So let's do HE. We'll leave E as x1, y1, and we'll call it H x2, y2. All right, so it'll be the same thing as we did before, x2 minus x1, -4 minus -1 squared, plus y2 minus y1, -3 minus -1 squared. Simplified in there, and I got -4 minus -1, so -4 plus 1, which is -3. And then I've got negative 3 minus negative 1. So that's like saying negative 3 plus 1. Which is what? Negative 2? So HE is equal to the square root of 9 plus 4, 13. Which means the opposite side of that, opposite side of HE is GF, is going to also be equal to the square root of 13. All right, so now I have all 4 of my sides. 1, 2, 3, 4. And I can find the perimeter by adding all those sides together. So my perimeter is going to equal square root of 10 plus the square root of 10 plus the square root of 13 plus the square root of 13. Alrighty, square root of 10 plus the square root of 10 is like saying 2 times the square root of 10. And square root of 13 times plus the square root of 13 is like saying 2 square roots of 13. And I really like this answer. Those are simplified radicals, and that's just fine. Lastly, we have our area. Now, to find the area, we got to do the base times the height. So I can, you know what? In this particular problem, unlike the last one, this one would be easier if we split it up into triangles. In the last one we did, we had some, I think there were some vertical lines. It was really easy to use those for the base and then go perpendicular to that with a horizontal line. This one doesn't have those horizontal and vertical lines, so I'm going to split it into 2 triangles. When I do that, I can call this the base of my triangle. And then this, I'll use the green for the height. Because those segments are perpendicular, that green segment can be my height. All right. So I've got 2 of those triangles in there. So I'll do 1/2 base times height for one of the triangles and 1/2 base times height for the other triangle. So it's easier to split it up into 2 triangles than to use the parallelogram formula. So this triangle on the left is going to have a base of 1, 2, 3. And it'll have a height of 1, 2, 3. On the right side, we're going to have a base of, let's see, 1, 2, 3. And go perpendicular to that with your height. 1, 2, 3. So our area of our left triangle will be 3 times 3 divided by 2, or 4.5. And the area of the right triangle will be 3 times 3 divided by 2, another 4.5. Add them together, and we get 9 units and square because we're talking about area. Woo! So the last one was a lot easier. So I guess try to do the good old area equals base times height if you can. And then if you come up with a problem similar to this one where you don't have an easy base and height, you could split it up into triangles. So you kind of have 2 options there. And I'll show you another option in another video.